In this video, I'm going to be looking at the displacement reactions of the halogens found in group 7 of the periodic table. And we're looking at the displacement reactions to try and work out the reactivity trend. So as you go down the group, do they get more or less reactive? In this dimple tray, I've already prepared some chlorine water, some bromine water, and some iodine solution. And to the first column, I'm going to add some potassium chloride. The second column, I'm going to add some potassium bromide. And the third column, I'm going to add some potassium iodide. And we'll come back to that in a few moments to see which ones have reacted. We can now see that chlorine has definitely reacted in these two reactions. Bromine has only had one reaction and iodine hasn't reacted at all. So we're now going to see what that tells us about the reactivity of the halogens. Well, just taking a quick glance at these results, we can see that chlorine reacted in 2 of its 3 reactions, bromine reacted in only 1 reaction, and iodine didn't react at all. So just straight away we can see that chlorine is more reactive out of the 3 and iodine is less reactive. We can also come to the same conclusion by looking at the displacement reactions one by one. So for example, chlorine and potassium bromide, there was a reaction, there was a colour change, so it turned into potassium chloride and bromine. You can see that the chlorine and bromine have swapped places. We say that chlorine has displaced bromine, it's taken its place. So that tells us that chlorine is more reactive than bromine. Another 2 chemicals that gave us a reaction was bromine and potassium iodide. So that turned into potassium bromide and iodine. Notice how the name of the halogen changes slightly when it's joined to something else, it ends in "ide". So what does this tell us? Well, the bromine has taken the place of iodine, so it's displaced iodine. And that tells us that bromine is more reactive than iodine. So what about when there's no reaction? It's quite easy to think nothing's happened, what was the point of that? But actually we can still get some useful information from the ones where there was no reaction. So if we take the case of iodine and potassium chloride, there was no reaction. So that tells us that iodine cannot displace chlorine. It can't take its place. So that tells us that iodine is less reactive than chlorine. So we're going to have a look now at the reactivity trend of group 7 halogens. That means how does the reactivity change as you go down the group or as you go up the group. So whether we look at the individual displacement reactions or whether we just take the first glance and see how many reactions the different halogens got involved with, this is the order we come up with. Chlorine reacted in 2 of its reactions and it can displace bromine and iodine, whereas iodine didn't react in any of its reactions and it can't displace bromine and it can't displace chlorine. So that tells us that as we go towards the top of group 7, they become more reactive. As we go further down group 7, the halogens become less reactive. Finally, we're going to try and write the symbol equations for some of these reactions. So if we take the first reaction we saw, which was chlorine and potassium bromide turning into potassium chloride and bromine, it's still worth writing the word equation first so you can sort out where everything needs to go. So chlorine is Cl2. All of the halogens form what we call diatomic molecules. That means 2 atoms forming 1 molecule. So chlorine will be Cl2. Bromine will be Br2, iodine will be I2, etc. So potassium bromide is KBr. If you're wondering why that's not, for example, KBr2, then you need to check out my previous video on how to write ionic formulas, and I'll put a link up to that one now. Similarly, potassium chloride is KCl and bromine is Br2 because that's another halogen. They go round in pairs in those diatomic molecules. So then we need to balance this equation. Now we can see we've got 2 Brs on the right hand side, so we need to get 2 on the left. That will need a 2 here. Similarly, we've got 2 Cls on the left, so we need 2 on the right, so we're going to put a big 2 here. Now, once again, if you've forgotten how to balance symbol equations, I'll put a link up to a previous video now so you can understand why we've put those big 2's in front of those formulas. We'll do one more example. So, bromine reacting with potassium iodide to make potassium bromide and iodine. So, bromine is Br2 as it's a halogen. Potassium iodide is Ki. Potassium bromide is Kbr, and iodine is I2. And then we've got 2 iodines on the right, so we need 2 on the left, so we'll put a big 2 there. We've got 2 Brs on the left, so we need 2 on the right, we'll put a big 2 here. So if you found the video useful, please give it a like, and in the next video we're going to be looking at how we can explain why the reactivity gets less going down group 7, or in other words, why the halogens become more reactive going up group 7, and that relates to their electronic structures. So make sure you check out that video. Thank you for watching.